Hi, my name is Harrison Butker, and for Lab 1, I chose to analyze the motion of a rolling basketball. In this lab, I will be looking at the change in position versus change in time to calculate initial velocity, and then see if my prediction of the ball having constant velocity is true. I will be using Tracker to look at the experimental model, then Python to demonstrate the predicted model. From there, I will enter the position and time points into a spreadsheet to show the comparison between the two graphs of position versus time. Let's begin. My prediction for this experiment is that the ball will have constant velocity in the specified time interval. For the ball to have constant velocity, the net force of the ball must be equal to 0. Although it would be nice to add up all the pushes and pulls that make this net force equal to 0, it is impossible due to the vast amount of forces that cancel each other out. In this experiment, there is some friction with the ground as well as air resistance slowing the ball down. However, when the velocity is taken in such a short period of time, the velocity should be almost constant. By looking at the experimental model, the ball looks to be going at a constant velocity. To get the position points, I had to give the program a reference of length, which I chose to be the diameter of the basketball. This is a standard length of 0.2385 meters, which can be seen right here. From there, I adjusted the axis so that the x-axis remained in the middle of the ball. As you can see, the x-axis remains in the center of the ball throughout the time interval. If we flip the x-axis, then all that would change would be the direction of the ball, the direction of that the ball was traveling. Instead of the ball traveling in the positive x direction, it would be traveling in the negative x direction. This would make the velocity of the ball negative. Now the ball would still be moving to the right, but instead this would be negative x, making the velocity negative. In order to make a predicted model of this behavior, I created a Python code that modeled the predicted behavior of constant velocity with zero net force. Here is my Python code, and here's what the predicted model looks like with constant velocity and zero net force. As you can see, this represents the basketball going in the positive x direction, and this is the graph of time versus position. And as you can see, constant velocity, and this looks very similar to the experimental graph. So in order to get this code to work, I had to insert some key things, for instance, the velocity. To find the constant velocity for the predicted model, I divided the difference between the first and second position points by the difference between the first and second points in time, and came up with 1.09 meters per second. And as you can see, I did 0.036 minus 0 divided by 0.033 minus 0, and that's where I get the 1.09. I also had to enter in the mass, which is, and the basketball has a standard mass of 0.624 kilograms. I then made the time interval 0 to 0.967 because, as you can see in our tracker, the time goes to 0.967, which is this point right here. Because I'm predicting that the rolling ball has constant velocity, I also made the F net vector equal to 0 right here. And then I inserted the equations to find final velocity and position, which come from Newton's second law, as you can see by final velocity equals initial velocity plus F net divided by the mass of the ball times delta t. The final position equals initial position plus the velocity of the ball times delta t. From here, I took the data and I entered it into a Excel spreadsheet, and I modeled the behavior. I made a line graph with the data, and as you can see, both the projected and experimental models are very similar. However, as time increases, the experimental model starts to diverge from the projected model. This is because the force of air resistance and friction are causing the ball to slow down. The projected model is very similar and almost identical to the experimental model. This means that my prediction of the ball having constant velocity was correct and is verified by the similarity between the two graphs. Thank you.